Well, so it's dawned on me. I've written down the pinouts this time because the way these sockets were, for instance, the old heaters went to pin 2 and pin 7. Well, these ones go to 4 and 5, and you can see I've got multiple choices on most of the other connections apart from the grid. Basically, the cathode, grid 2 and the anode, I can choose one of 2 connections, which is quite handy. But the grid has to be on pin 7. Well, the old grid was on pin 5, whereas the heaters are now on 4 and 5. And the old heaters are on 2 and 7. Well, if you look at a valve socket, you count round clockwise direction from the underside, pin 1 round to pin 9. Well, I had the sockets in this way round. Let's have a look. Yeah, 1, 2, 3. This way round, because obviously the heaters were going to pins 2 and pin 7. Well, the heaters and some of the other connections now would be all over the place. It's actually worked out if I take the sockets out, turn them around. So as you can see, 1, 2, 3, 4, 5. So 4 and 5, the heaters can connect straight to there. So the heat wiring, depending on how melted it is, because obviously all this wiring's took a bit of a hit heat-wise. You can see quite a lot of the insulation's melted back, desoldering it. Some of these resistors were all right. I've only ditched a couple. Some of them were, you could feel the leads had gone brittle and stuff. So yeah, but these seem okay. I should give them a good test with the multimeter before I actually solder them back on once I've rewrapped the leads. And a bit of a jiggle, but so yeah, I've decided it's going to be better to take the sockets out, spin them round. So yeah, I'm not looking too bad, to be honest. I've had to think about it, and with the options I've got, I should get away without having to replace a great deal of this wiring at all. With a little bit of rerouting, it should go to where it needs to be. So not as bad a job as I originally thought. Just a bit of a mess. But I mean, it's taken me about 45 minutes to take these sockets out, so that wasn't too bad at all. Oddly enough, first socket I started on soldering was this one. Did the first joint, I thought, what are you doing, Liam? That one's all right. That's the only one that was all right. So I don't know. You just get your work head on, don't you? So anyway, yes, they're out. Next part of the video, they'll be back in again. Right then, so I've been tinkering about today, and let's see if I adjust my volume. So I'm just feeding this a 1 kilohertz square wave. I'll get back to what it's showing me momentarily. So anyway, as for the annoying repair I had to do, the valve sockets, it was easy to spin them round, so I spun them round. Managed to reuse 90% of the wiring, so just a few wires I've had to change. Just put a few different bends in, take a few bends out just to get the lengths right. So things I've been messing about with today, well, I'm going to have to do something with that because these resistors are getting quite hot in standby mode. Say they're 3 watt rated, and they're only passing 2 watts, yet they're getting absolutely hot and smoking. So that's why you don't buy resistors off eBay. You can see here, so a few resistors stood up on this board. I've just been tweaking the values as she was misbehaving a bit, oscillating. So yeah, just had to order feedback components just to get it to behave itself, which it's doing now. So square wave testing. This is in triode mode. Let me just update. This scope, these waveforms aren't asymmetrical. For some reason, on the 500 millivolt per division setting, this scope, obviously I've got these 2 waveforms inverted. For some reason, it obviously doesn't quite load up equally. It draws it. You have to sort of just off-center the point for the graticule to get it to work right, but meh. So anyway, this is triode mode. If I switch it over to pentode mode, you see slight bit of ringing, so I'm just messing about with some component values. You notice how the gain went up then as well. So at present I'm just shunting the output of the driver stage long tail pair. If I take
You see I'm getting a lot of ringing. It's not oscillating anymore, but that's ringing like crazy. That's no good. So I shall just be messing about some values. I'm going to try just a few bits and bobs, see which way works out best. This is, there's no hard rules here. You literally just have to experiment until you find out what you want. So a lot of this is actually because these wires are twisted together and running up here, it's sort of injecting. One of them rings, it injects into the other one, that then rings, and it's sort of a bit of a feedback loop going on. So I can you can't really see it, but it is. I can just by moving the wires about, I can get it to alter in slightly. So yeah, anyway, next is get this fucker sorted out and hook a speaker up to it, see what she sounds like. Right then, so I've been having a bit of a play about. I can't quite remember as I'm filming this what it looked like on the last video. I seem to think it was ringing a bit more than this. So anyway, typed a few values in here. The impedance of this driver stage is quite low, so it's needed quite a lot of shunt capacitance to actually tame it. A bit more than I initially calculated, but I'd altered the design since then. So it's a bit of minor ringing. That's the joy of using output transformers. You're going to get phase shift. Oh yeah, this doesn't help, all this wiring. It's not going to be helping things, but this is with just 100 ohms of load on it. If I put a 10 ohm resistor across here on the output, ta-da! So yeah, and this is in pento mode. If I switch to triode, so you can see it rounds it off nicely, obviously because they're now running with local feedback on the screen grids. And if I load up a triode, you see it just basically affects the amplitude rather than the signal much, but it's not bad for a valve amplifier with output transformers. Asking it to even pass any kind of a square wave, you're going to have spent some good money on iron to achieve that. So this is acceptable. This is fine. So next I'm going to sort this out and then hook a speaker up to it. Well, it is working. Done a few tests on it. Did a spectral analysis just using the FFT on my oscilloscope. It just, whatever harmonics were being generated were just lost in the noise floor of my scope, even right up it to 10 kilohertz. Like there would have been a second harmonic at 20, third harmonic at 30. Couldn't see anything. Messed about, got the frequency compensation right. You can see I've had to just tack, if it focus, a couple more caps on to the input resistors. Just up and down that ringing quite nicely. Frequency response, did a full sweep. It's absolutely flat up to about 18 kilohertz, and it just starts to roll off, which is perfect, really. That's more than acceptable. That's in both triode mode and pentode mode. In pentode mode, the roll-off's a little bit later, a little softer, because obviously you've got a bit more negative feedback until these caps really take over and start shunting the drive away. So I'm just going to check some voltage before I turn it off. I've got to still hook up this little plug down here to the cathodes for the remote valve checking, and got to sort out this standby thing and then do the wiring, and that is it. I've put 10 ohm resistor in here because this was just creating a little bit of hum, having 2 points to the 0 volt rail. Obviously this is at the very start of it, this is at the very end of it, and yeah, just connecting this up was a bit of hum, so putting 10 ohm in there's killed that dead. I just like having multiple reference points to the chassis, just, you know, a little bit safer. So I'm going to check some emission because I had a dodgy valve. So if I look there, 11.6 volts, cathode resistor 11.38, it's pretty close. Going to be some natural variation. 11.42, 11.3. So that's one side, that's the other side of the amplifier, I think. Yeah, it is. One of the valves I first put in, even after giving an hour of soaking, barely got above 9 volts emission. So yeah, that one's now on the shelf with some pen on it pointing out that it's a bad valve. Check heat supply voltage. Remember, it is essentially tapped to 0 volts, so I should 3.15 or so. It's going to be a bit low on resolution of a 20 volt scale, but 3.01, 3.05. So yeah, it's going to be, it will be about, let me move my 0 volt point actually onto the bugger off screwdriver, onto the heater supply pins. 6.07. It's a little light, but it's within tolerable limits. Again, if I'm taking this board off, I can always just drop one of those resistors out of there just to get the heater back up to where it wants to be. But that's the joy of building something yourself. So, you know, it's the first, when it's the first time you've built a certain design, it's never going to fire up and work exactly as it should at the first press of the button. So I had a lot of issues with oscillation, a lot of issues with oscillation. I had to change the values of these twice before I killed that. Then obviously trying to just get the frequency compensation right to try and, you know, compensate for all the capacitance and inductance in these wires. It's interesting, even with the feedback circuit from one amplifier disconnected so it can't oscillate. By the other one oscillating, because there's so many wire runs next to each other, it would actually capacitively or radio frequency or inductively couple, or a combination of all of them. The oscillation at high kilohertz, it was sort of way up in there, way up. It was high frequency oscillation. It would actually couple it into the other stage, the other amplifier, and that would start oscillating too. So yeah, it's, you see, it's on at the minute. Power supply says it's on. Power supply's not got a lot of voltage across it actually. This transformer's quite heavily loaded up when it's running. Obviously as these valves age and emission starts to go down, there'll be less load on the power supply and that regulator will come into play more. In a minute it's only about 12 volts across it, so it is regulating, but it's having a very easy time. Obviously if these age, as the current goes down, the voltage in this capacitor is going to go up, and that's going to keep everything exactly where I wanted it. Changed my input valve. It was a 6N1P EV, which I know I said in a previous video, people on eBay love selling them as a 6DJ8 E88cc. They are not. They're a very different valve. The valve that's in here now is a 6N23P, which is a copy of a ECC88. So if I probe the voltage, I actually want to see what that is. So if I just shove this on a 0 volt point. So the 6N1P would have about 100 volts across it. You know, I've not changed any resistors. So if I go to the anodes of the 6N23P, you see 81 volts, 20 volts difference. And the cathode voltage, it's going to be, see, look, over 2 volts. The 6N21P, 6N21, whatever I just said it. Hang on a minute. Sorry, I've completely lost. I've been saying that many bloody numbers and looking at that many things today. 6N23P, 6N1P, isn't it? Yeah, 6N1P. So yeah, the 6N1P would only bias about 1.7 volts on the cathode and would have 100 volts across it. So obviously there was less voltage, less voltage across the anode load resistor, more voltage across the valve, drawing less current, so obviously less cathode current, less voltage. We can see the ECC88 clone, rather than 1.7 volts, has 2.2 volts across the cathode and only 80 volts across the valve. You can actually hear it making the speaker click because that speaker's connected. So 81 volts across the valve, 82 volts across the valve. It's quite nicely matched. So yeah, so I'm going to leave it for tonight because it's getting on. I'm going to just chill with some telly, maybe have a beer. Fucker, it's been a warm day today. It's middle of October and look, it's 25 degrees in here, or 24.9, call that 25. Absolutely roasting. So tomorrow it gives it about 12 degrees and pissing down. So probably just come back in here at some point tomorrow, tidy this wiring up, actually put it back together and take it downstairs and have a good old listen to it. But for now, this is as far as I'm going to get. So